All right, you guys, question number 3. Proxima b is a new Earth-like planet recently found by NASA. It is a mere 4.2 light years away from our solar system. There are approximately 9.5 trillion kilometers in 1 light year. To the nearest kilometer, how far is Proxima b from Earth? I changed the 9,460,528,400,000 kilometers to 9.5 trillion kilometers. Because our calculator freaks out when we have to do the multiplication for this. So just remember, we're talking about trillions of kilometers in our answer. And you can see I already have set up my proportion. So 9.5 trillion kilometers in 1 light year is equal to how many kilometers? That's what I want as my answer in 4.2 light years. So if I just multiply, I'm using a new pen here today, so don't make fun. If I multiply both sides by both denominators, 4.2, those are parentheses, I'm sorry you guys, and 1, that 1 doesn't really matter, right? And the same on this side, we'll do 4.2 and 1. That's a 1, okay. And then we can do some canceling, right? This one here cancels with this one. This 4.2 cancels with this 4.2. And I have 4.2 times 9.5 over there, which I did, which is 39.9 is equal to, I'll get the hang of it, you guys, I'm sorry. X times 1, which is just x. So I already have my answer. It is approximately, and these are approximately because we did so many rounding, 39.9 trillion kilometers from Proxima b to Earth. And this is question number 4. And remember, I think we did this in class the other day. We're talking about catching and recatching and tagging animals, and how do we know how many are in the population altogether. So I already put my total moose population on my denominator here. That's the total population I want to keep track of. Okay. And she randomly catches and tags 50 moose and re-releases them. So that's our original tagged, okay? Tagged. And we're going to set up a proportion. This is the total moose down here, the total population. What's the other number we have? We have 2 more numbers, a 75 and a 20. She then catches a sample, and then the total sample is 75 moose. And we put the total sample down with the total population, and then the number of tagged here on the numerator. Remember, on a proportion, the units on the numerator and the units on the denominator have to stay the same. So this 20 is the tagged, and the 75 is the total population of that sample. And then we're going to, let's see, let me erase this so that we can view, see what's happening. We're going to multiply both sides by m and by 75, because those are our 2 denominators. Okay, and then this side also by m and by 75. I can't make that cross in my 7. Sorry, guys. And then my 75s cancel over here, and my m's cancel out over here. And I have 75 times 50, which is, 3,750. So 3,750 is equal to 20 m. Okay, and then we're going to divide both sides by 20, divide this side by 20, and these 20s are going to cancel out. They're not going to cancel, they're going to become a 1, and the 1 doesn't really mean anything because you multiply it by m, you get m back. So then we have 3,750 divided by 20, and that looks like 187 7. Oh, those 7s are going to kill me. 0.5. There's a point there. And that's going to be the total moose population. So don't forget to write these answers in words with units. So the total approximation of the moose population is 187.5. And that's an approximation, of course, because we're not going to have 0.5 of a moose just hanging out. All right, you guys, question number 5. There's one very similar on the test. Your car's gas tank holds 18.6 gallons and is 1/4 full. Your car gets 16 miles per gallon. You see a sign saying next gas is in 73 miles. You're often wrong, brother. Who's driving it? Sure you'll make it without running out of gas. Write and solve a dimensional analysis expression to tell if he's right or wrong. So what do we know? We know we have to go 73 miles. So what we need to know is that if the amount of gallons of gas we have in our tank is enough to get us there. So how can we write a dimensional analysis problem to solve this? So let's start off with what we want. We want to know how many miles we can drive on the amount of gas we have. So I want to put right away whatever I know about miles, I want that in the numerator. So I know that my car gets 16 miles, and I'm just going to use an M, per 1 gallon. Okay, and now I know what's going to have to come next because I'm just going to concentrate on crossing off this gallon. So I know that my car holds 18.6 gallons in 4/4 of my tank, right? The whole thing, 4/4. Okay, and then that's a Q right there. What do I know about quarters? I know I only have 1/4 left in the whole tank, okay? And we just need 1 tank down here. Sorry about this, guys. Hopefully you are listening to this so you can hear what I'm saying and not just watching because the writing's pretty awful this time. And so is equal to, so we multiply everything on the numerator, so 16 times 18.6 times 1, which is 297.6, so 297.6 divided by 1 times 4 times 1 tank is just 4, right? And then so what I'm going to end up is after this gallons cancels out and this gallons and this quarter and this quarter, I'm going to end up with how many miles I can go with what's left in my tank of gas there, right? So that's equal to, let's divide that by 4, 74.4. So let's see, 74.4 miles. I can go 74.4 miles with what's left in my tank. So was he correct? He was correct by just 1.4 miles. The second part of this is if gas costs $2.59 per gallon, how much money will it cost them to drive to the nearest gas station? The question wants how much money will it cost them, so I need to start off with money. So I know $2.59 is money. And I'm going to put that in the numerator because that's what I want as an answer. What do I know about that? It's dollars per 1 gallon, right? So now that I have gallons here, I can put gallons up here. So what do I need to put up here for gallons? What do I need to put up here for gallons? I know it takes 1 gallon to go how far? 16 miles. And what do I know about miles? I know I have to go 73 miles. So that's how much it's going to cost me to drive 73 miles. So 73 times 259 is 189.07, and then 1 times 16 on the denominator is just 16. So my answer is going to be approximately $11.82. And I'm not going to write this here, but it is $11.82 if I multiply everything on the numerator, and then I divide that by everything on the denominator. That's the amount of money that it's going to give me back. So right here you should have 189.07, and here you should have 11.82, and that'll give, or I'm sorry, 16, and that'll give you $11.82. All right, you guys, Adeline's parents in France decide to buy a new electric car. They purchased a BMW i3, which travels 180 kilometers on 107-minute charge. Sarah's parents opted to purchase the new Tesla 3, which travels 250 miles on 1 4-hour charge. Adeline and Sarah want to know which car is more efficient. So it doesn't matter which one I change, whether I change kilometers per minute to miles per hour, but as long as they have the same rate, as long as we're both talking about kilometers or we're both talking about miles, I'll be able to compare them directly. So I'm going to find the unit rate for Sarah's car. If Sarah's car, her parents opted to purchase the new Tesla, which travels 250 miles on 1 4-hour charge. So the unit rate for that would be 250 miles on 1 4-hour charge. So that means for each 1 hour, it's going to be, let's do the math here, 62.5. So she can drive 62.5 miles for every 1 hour of charge, and that's Sarah, right? And now let's look at Adelaide's is 180 kilometers. We want miles per hour charge on this one too. So I'm going to figure out a way to put miles on the numerator here. So what do I know about miles and kilometers? I know that there's 1.6 kilometers, right? I think we know that. Kilometers for 1 mile. Oops. But what did I just say? I want to get miles on the numerator, so I'm going to delete that. Oops. I'm going to hopefully learn how to use this. Delete this. Oh, look how pretty. Okay. So I definitely want miles on top, so I have to put 1 mile is 1.6 kilometers. Ugh, this is hard to write. And then what do I know about kilometers here? I know that she can travel 180 kilometers. See how I knew what to put there? Kilometers over 170-minute charge, 107 minutes. Min. I have to put min there since I'm using M for mile. And then how do I change minutes to hours? Easy peasy. I know there are 60 minutes in 1 hour. Okay, so what this does is this equals 18 times 60 on the numerator times 1, which is 1080, over 107 times 1.6 times 1, 171.2. And then I divide, and let's make sure everything cancels out. This miles. Oops, the mile doesn't go away. We want that mile. This kilometer, this minute, and what I have left is miles on the numerator and hours on the denominator, which is exactly what I want. So I want 1080 divided by 171.2, and I get approximately, hold on one second. And I forgot to make this, sorry you guys, it was 180. I think I said it and I wrote it down incorrectly. So 180 times 60 times 1, which was 10,800 divided by 171.2, which is 63. Approximately, oh, this is going to be close, you guys. It's going to be approximately 63.08 miles for 1 hour of charge. So whose does better? Well, it looks like just Adelaide by just like 1 mile, half a mile maybe. Adeline, just by a little bit of time. Don't forget the test. In order to get full points, you're going to have to write your complete sentence here. Write sentence. Oh, this is easier when you're writing in cursive. Here. For complete points, which would sound something like Adelaide's car is more efficient because hers gets 63.08, approximately 63.08 miles out of 1 hour of charge, and Adelaide only gets 62.5 miles, or Sarah only gets 62.5 miles for every hour charged.